In this section, we will discuss the 5G network deployment options. What are the options that the operator have in order to move to 5G network? Initially, the 3GPP has defined the multiple deployment. So the operator has many options to choose one of them to go to the 5G network. But the most highlighted ones are options 1, 2, and option 3. Of course, there are other numbers of options which are making use of the LTE to move to the 5G network. But as we mentioned before, the three deployment options, which are option 1, 2, and 3, are the main options that are discussed in the standards. The first one is option 1, which relies on existing LTE APC architecture. The second option is a target architecture with a standalone new radio and 5G core. The third option is option 3. We call it dual connectivity, and it is the best short-term alternative for 5G deployment. Why? Because it relies on existing LTE and the EPC when connecting the new radio. The different deployments are based on either we are expanding the 4G network to make use of some 5G features, or we are establishing and building a fully new 5G network. The industry has decided to base the initial deployment of 5G only on two options, option 3 and option 2. Why? Because the other options don't have direct steps leading towards a long-term 5G target architecture. Of course, there are some differences in cost, in timelines, and complexity between the two options, and this is also mainly depending on the use cases that are applied and used by the operator, and also the readiness of the operator who are implementing the deployment. So let's have a quick look into the two options offered or highlighted by the standards. The first one is called the non-standalone NSA and also referred to as connectivity option 3. In this option, the throughput of the device can be increased by connecting the new radio of the 5G to the 4G radio, and this is called EUTRAN NR dual connectivity. The second option of 5G deployment is a standalone. It's called SA or option 2, where the user equipments are connected using only 5G technologies, new radio, and the 5G core. So let's start by focusing on the first option, which is the non-standalone architecture, NSA or option 3. In this configuration, only the 4G services are supported, but enjoying the capacities offered by 5G new radio, like the lower latency and the higher data rates. The non-standalone option is mentioned or is called as EUTRAN dual connectivity, ENDC, or option 3. And of course, the mobility between E node B and new radio, G node B, is supported. In the non-standalone architecture, the 5G new radio base station, which is G node B, is connected to the 4G LTE base station, E node B, through the X2 interface. And in this dual connectivity mode, the 4G E node B is the master, while the 5G new radio or G node B is the secondary node. The non-standalone architecture can be considered like a transit stage towards having full 5G network. This option will allow to make use of the existing 4G network plus some of the new 5G services and applications, mainly enjoying the capacities offered by 5G, new radio, especially the lower latency. However, you should note that the use of option 3 or non-standalone architecture of the dual connectivity introduce some challenges. One of the main limitations of option 3 is that it is not providing the 5G core-enabled capabilities, like for example connecting user equipment to multiple network slices at the same time, like the edge computing support and operational benefits, although the EPC can also support these services to some extent. The second deployment option recommended by the 3GPP is option 2, which is a standalone architecture, and it can be seen as a full 5G deployment. It doesn't need any part of the 4G network to operate. In this case, the new radio is connected to the 4G core network, and only in that configuration, the full set of 5G services are supported. You should note that the target architecture for the 5G migration is to use the standalone new radio and the 5G core as far as possible. Comparing with the non-standalone deployment, the 5G standalone option 2 provide better enhancements in uplink, also in end-to-end latency, and in edge computing, and therefore it provides much better user experience. The mobile operators can choose to deploy fully isolated standalone option 2 network for verticals like vehicles and industrial automation in dedicated spectrum, while keeping the 4G network or mixing it with non-standalone option 3. As discussed, the ultimate goal for all operators or for the network is to reach the standalone architecture. So, we should have a migration path from the non-standalone option 3 to standalone option 2. Standalone option 2 architecture can provide, as we said, the full 5G potential, and it offers all supported features of the 5G, and it has all capabilities that support vertical industries like IoT and industrial automation. So generally, the standalone option 2 would be an important evolution direction. So there should be a possible migration path to this option. So in order to migrate from option 3 to option 2, we have two stages for migration. The first stage, non-standalone option 3 and the standalone option 2 cells serve both standalone option 2 and the non-standalone option 3 user equipments at the same time. And in cell selection procedure, non-standalone option 3 user equipments camp on LTE cell, while the standalone option 2 user equipments camp on U-radio cell. And then during this first stage, operators will be encouraged to introduce standalone option 2 user equipments to accelerate the migration to stage 2, which is the full 5G stage, to make use of the use cases and the opportunities available for them that can generate revenue for the operator and can generate much better experience, of course, for the user and for the IoT devices. And here, a list of the references that you can try to visit in case you need to get more information and more details about the different topics that we are discussing throughout the course.